In this video lecture, we are going to see about the timers of PIC microcontroller. So in the previous video lecture, we have seen about the general architecture of PIC and then the register file structure, then the special and the general purpose registers, addressing modes. So we have seen these of PIC microcontroller. So from today's video lecture, you are going to learn about the timers of PIC microcontroller. So before we go to timers, what the purpose of timer in PIC microcontroller is. So if you want to measure, not in sense of measure, if you want to know the time period of a particular event that has been occurred in PIC microcontroller, using timer you can know it. Fine. For example, an event has been occurred at a particular time of 2 microseconds. Fine. So it starts at 2 microsecond, and if you want to know to how long that event has been occurred, okay, the period of that event you can measure it using the timers of PIC microcontroller. That's the one purpose of timer. So when you use this timer as a counter, you can even count the number of time that particular event has been occurred. Fine. So for example, if we take an event like if someone is entering into a hall, okay, so at that time we will fix some sensor, okay, IR sensor, for example. For IR sensor at the entrance of the room, if someone is crossing that sensor, which means that from the transmitter and the receiver the signal will get interrupted. That means the signal is get interrupted since a person is crossing that sensor, okay, between the sensor, okay. So how many times a person has been entered, okay, that you can count. So whenever a person is interrupting, that means entering into the room, this register, that means the counter register will starts to count, okay. So if you want to count the number of times of a particular event occurred, you can use this timer register. Fine. So the another purpose is that if you want to create a delay for an occurrence of an event, okay, you can use this timer. Fine. Okay, these are all the purpose of the timers. If you want to measure an event period that has been occurred, you can use timer. If you want to count the number of times that event has been occurred, that is that you can do it using the timer. Another purpose is that if you want to create a delay, fine, you can use this timer. So these are all the three main purpose of the timers of PIC microcontroller. Fine. So in general, most of the PIC families will have only 3 timers. So advanced PIC families will have 5 timers. So basic PIC families will have 3 timers. Okay, we will discuss about the 3 timers in this video lecture. So in general, we are going to discuss not a particular timer of a particular family. We are not going to discuss. Fine. So generally in PIC microcontroller there are 3 timers. One is timer 0, then timer 1, then timer 2. So these are all the 3 timers of PIC microcontroller. So in this, the timer 0 and timer 2 are 8-bit timers, okay. Then timer 1 is of 16-bit timer, okay. So first we will see about timer 2 and then we will discuss about timer 0. So before we discuss about timer 2, we will discuss generally how the timers work. Fine. Okay. So generally the timer will have some register called as timer 0. So each and every particular timers will have its individual timer register. Fine. So in general we will discuss it now. We will have a timer 0, which is for example I will take it as an 8-bit. Okay. So for this timer register we will give the clock pulse as an input. So like this, we will give the clock pulse, okay. So this clock we will take internally or externally, it depends on the programmer. Fine. Okay. So what will happen is, okay, so this register will at the initial time it will be initialized to 0 0 because it's a 8-bit, no. So it is initialized with 8-bit value 0 0, okay. So whenever this timer register receiving a clock pulse of a rising edge, okay. So for example, we have taken a rising edge. It depends on the programmer whether he can configure it for rising edge or falling edge. It depends on the programmer. So here I have taken the rising edge, okay. Whenever the timer register is receiving a signal with rising edge, it will count that means it will increment to 1. So now the 0 0 will increment to 0 1 when it receives first rising edge. Okay, so then the second rising edge will come. Now at that time the 0 1 will be incremented to 0 2. Okay, when it receives the third rising edge, it will increment to 0 3. So this process will continue unless it reaches its maximum value ff. So because the least value of 8 bit is 0 0, the most value of 8 bit is ff. Okay, so till then, till it becomes ff, this timer will continues incrementing whenever it receives the rising edge of the clock pulse that we given to this register. So once this reaches the most value ff, an interrupt will be generated, okay, out from this timer. So this interrupt we used to call it as overflow interrupt. So why overflow in the sense? So the most value of this 8-bit timer register is ff, fine. So this ff is the most value, so it reaches the most value, so it gets to overflowed. Okay, whenever it reaches the most value ff, an interrupt will be generated. So this interrupt we can use it for the three purposes that we have stated before, the purpose of timers, fine. So it is not must that it should reach ff. You can make you can give the most significant value, most value in the program itself. If you want to reach 60, so then in program you can define it as 60. So whenever it get incremented, it will be compared with the value 60. Okay, so when it reaches 60, it will generate an overflow interrupt. So this is how the timer works, fine. So with the time you have, in specific for each and every timer we have an timer register. Okay, so that will be initialized with the value 0 0. So whenever it receives the clock pulse, okay, either on the falling edge or rising edge, this register will starts to increment, fine. So when this register reaches its fixed value, okay, that we given in the program, so then an interrupt will be generated. Okay, so this interrupt, with this interrupt we can reach out to the purpose of the timers, fine. So first we will see about timer 2. Okay, so as I have already told you, this timer 2 is an 8-bit register. Okay, fine. So that register is TMR2. Okay, so this is an 8-bit register. So before this 8-bit register, we do have two scalar values. One is pre-scalar, another one is post-scalar. So pre-scalar we have to use it before this timer 2, and post-scalar we have to use after timer 2, fine. So this pre-scalar is defined with the value 1, 4 or 16. Okay, the post-scalar value will be defined from 1 to 16 value. Okay, so what's the purpose of these scalar in the sense? So with this scalar only we will give the clock pulse. Okay, so this timer 2 will operate only in the internal clock. So internal clock is nothing but the signal that we get from the crystal oscillator that we use in our PIC microcontroller, fine. So we will give our input clock to this pre-scalar. So that clock pulse, oscillator clock pulse, should be divided by the 4 at the initial time, fine. Okay, so as I have already told you, here we do have our clock pulses. We will define whether it should count, that means it should increment with rising edge or falling edge. So for example, here I will take falling edge. For example, I am saying, fine. So I am giving this clock pulse to this pre-scalar value. So if I have defined 1:4, okay, so if I have fixed the value as 4 here, what will happen is, for every 4 falling edge, fine, for every 4 falling edge, I will get a single clock pulse as an output from this pre-scalar register. Okay, so 1:4 in the sense I will get 1 clock pulse as an output. Okay, so if I get for every 4 input clock pulse, fine. So here we will give our clock pulse as an input for every 4 falling edge, or else, so if you have doubt in the falling edge, you just leave it. For every 4 clock pulse, for low and high, for every 4 clock pulse, one single pulse will be given as an output from the pre-scalar value, fine. So which means that the clock pulse that we given as an input oscillator by 4, which means that, for example, if my oscillator is 4 megahertz, if I divide it by 4, then the internal pulse frequency will be 1 megahertz. So this 1 megahertz is again divided by 4. So that's the meaning for here. Okay. So for every 4 clock pulse, I will get a single clock pulse as an output from the prescaler. Okay. So next thing is our timer 2 register, which is nothing but a main scalar value. So this main scalar value can be defined from 1 to 256 or 0 to 255 as a count. So this value I have to store it in PR2 register. Here it is. Okay. So this I have to mention in PR2 register. So what will happen here is, for every single pulse that received by this timer 2, so this counter register will be incremented. Initially this value will be 0 0. So when it receives a single pulse here, this will be incremented to 1. Okay. So then the next single pulse from this output of this prescaler, it will be increment 2. So whenever this timer 2 register is incremented, it will be compared with the value with the PR2 register. So in this PR2 register, we will predefinedly will store the scalar value from 0 to 255. So for example, I will have stored the value 8 here, 0 8. So what will happen here is, when this timer 2 register is having a single clock pulse, received a single clock pulse, it will be incremented to 1. So this one will be compared with the 8 using the compare. Okay. So it will check whether these two are equal. If it is not equal, it will again count if it gets the another pulse as an output from the prescaler. Okay. It will be incremented to 2. Then it will check with 8. So if it is equal, means it will given clock pulse as an out, otherwise it will again check on to the input pulse from the prescaler. Fine. So this will continue till it reaches 8, till this timer 2 reaches 8. So if this timer 2 reaches 8, now it compares these two values, it is equal. So then it will generate a clock pulse as an output. So now this clock pulse is input for the post-scalar value. So here in the post-scalar register, I can fix a value from 1 to 16 or 0 to 15. Okay. So this if I have fixed to the value 2 in the sense. Okay. So what it will do is, it will initially it will have the value 0. Okay. It will, when it receives the pulse, it will be incremented to 1. Okay. So again, if it receives another pulse, it will be incremented to 2. Okay. So now it reaches the value, so which means that it got overflowed. Okay. So because of this overflow, an interrupt will be generated. Okay. So we will discuss this interrupt part later. So now we will once again discuss this timer part. Okay. So for prescalar, for timer 2, we do have a prescalar and post-scalar value. Okay. So we will initialize this prescalar and post-scalar value with the predefined value. Prescalar can be of 1, 4 or 16. Post-scalar can be of 1 to 16 value. Okay. So if I fix it the prescalar value with 4, what does it mean is, for every 4 clock pulses, it will give one single pulse as an output. That's the meaning for this one. 1 is to 4. Okay. So again, I have given a main scalar value with PR2. Okay. Whenever this timer 2 gets an input from the prescalar, that means the pulse, it will count, compare with the PR2 register. If it is equal, then it will generate an pulse, or else it will look on to the output of prescalar. Okay. If it receives the pulse, it will again increment it. So this is how main scalar works. Okay. So next one is post-scalar value. If I assign to 2, in the sense 1 is to 2, which means that whenever it receives for every 2 pulses post-scalar receives, it will generate an interrupt outside. So that's the meaning here. Okay. So as the total cycle completes, I have to multiply all these values to have a total time period. Fine. So this is how the timer works. Okay. So your prescalar output is given to the main scalar, and the main scalar output is given to the post-scalar. When your post-scalar overflows, an interrupt will be generated. So it depends on the this time period depends on the count that we given to those registers. Okay, so for example, prescaler I have taken a value 4. You can also take a 16. So if 16, in the sense, for every 16 clock pulses it receives the prescaler. Okay, for every 16 clock pulse it receives, it will generate a single output signal. Okay, so that is given to timer 2. Fine, it will count and compare with the PR2 register, main scalar value. Okay, if it matches, it will generate an output signal. So if that is given to the post scalar, fine. So if I set a post scalar with the value of 5, in the sense, for every 5 clock pulses, so this post scalar will generate an interrupt signal. Fine, so this is how the timer works. So now we will see to the interrupt part. Okay, so whenever an interrupt occurs, obviously it will obviously the controller transfers its controller to the subroutine program. Fine, so that's the logic till now we have discussed in the previous lectures. Okay, so whenever an interrupt should be recognized, which means that whenever an interrupt occurs, if we want to jump on to the subroutine, that particular interrupt should be enabled. So that's the logic. This also we have discussed already. Fine, so whenever interrupt should be recognized, that interrupt should be enabled before we start up with the program, right? So those things will also should happen before we start up with the timer's operation. So for every timer, okay, for every timer we do have an every timer register, and then a particular interrupt pin and particular interrupt enable pin also. So we should enable it in the particular register. So that we will see it now. Okay, so the timer that we are discussing is timer 2. Okay, the interrupt generated by the timer 2 is timer TMR, timer 2 interrupt flag. Okay, so this is in the register PIR 1. Okay, whenever this post scalar overflows, so this bit will automatically, bit number 1 of PIR 2 will automatically set to 1. Okay, so this is not writable register. Okay, this will set automatically whenever the post scalar overflows. Okay, so if the controller wants to recognize this interrupt, fine, its particular interrupt enable bit should be enabled, it should be made to 1. So that enable bit is TMR2IE, timer 2 interrupt enable bit. So this is in the PIE register, peripheral interrupt enable register. Fine, PIE. So in this, the bit number 1 should be made 1 by the programmer. So this should be done by the programmer. We should enable it so that only this interrupt will be recognized. Okay, so this also should be enabled, and then 2 bits that are must to be enabled. Okay, so those 2 bits are peripheral interrupt, PEIE, peripheral external interrupt enable bit, and then GIE, global interrupt enable. So we know this already, global interrupt. Previous video lecture itself we have seen about this. Okay, so this bit, peripheral external interrupt enable bit, should be enabled for all those timer interrupts, analog to digital converter interrupts. Okay, this is the must thing. So this bit resides in the register interrupt control register, INTCON register, interrupt control register. So in that, bit number 6 is PEIE and bit number 7 is global interrupt enable. So global interrupt enable should be enabled to recognize all those 12 independent interrupt sources. So in the feature itself we have discussed that generally the PIC microcontroller is having 12 independent interrupt sources. So these interrupts should be, as a whole, should be enabled by using global interrupt enable bit. Okay, so this resides in the register INTCON register, interrupt control register. So these 2 bits should be make enabled. Okay, then only this particular interrupt will be recognized. Okay, so as a whole, so when these bits are enabled, this interrupt will be recognized and it will be given to the CPU, which is nothing but your microcontroller. So this is how the timer works. Okay, so next we will see how we can set this pre-scalar, main scalar and post scalar values. Fine. So we do have a separate register called timer to control register, T2, timer to CON, timer to control register. So in this, the bit number 0 and bit number 1. Bit number 0 and bit number 1 are used to set the post scalar value. Okay. So, bit number 0 and bit number 1 will set to are used to set the post scalar value. Okay. So, then the bit number 3 to bit number 6 are used to set the pre-scalar value. Okay. So, when we give value to this register, you can set the pre-scalar value, either it can be 1, 4 or 16. So, this can be from 1 to 16. Okay. And bit number 2 is to on and off your timer register. So, if the timer 2 on, this bit name is timer 2 on. If this bit is 1, the timer 1 is enabled. If this bit is 0, the timer 2 is disabled. That is the meaning for that. Okay. So, using the timer control register T2 con register, you can enable or disable the timer 2, and as well you can fix the value for post scalar and pre-scalar value. So, the least significant 2 bits are used to set the post scalar value, and most significant 4 bits are used to set the pre-scalar value. Fine. So, and then by using the PR2 register, you can define the main scalar value. Fine. So, we are having a separate 8-bit register, PR2 register. Using this, we can set the main scalar value. If all those 8 bits are 0, which means that I am setting the main scalar value as 1. Okay. If all those values are 1, I am setting a main scalar value of 256. Okay. So, this is how by setting the value or giving the value to these two registers, T2 con register and PR2 register, we can set the main scalar, post scalar and pre-scalar value for the timer 2 functioning. Fine. So, next we will see about the interrupt logic. Fine. So, as I have already told you, to recognize an interrupt and to perform the ISR, the particular interrupts enable bit should be enabled with all those global interrupt enable and then peripheral interrupt enable bits. Fine. So, we will see that now how we can enable and disable those interrupts. Okay. So, as I have already told you, in the interrupt control register, the bit number 7 is global interrupt enable. So, this controls all possible interrupt sources simultaneously. So, if this bit is 1, which means that all those 12 interrupt sources are enabled. Okay. And next thing is PEIE. Okay. So, this global interrupt enable bit is meant for all those software interrupts and as well as the hardware interrupts. Fine. So, the hardware interrupts can be of an peripheral interrupt or it can be from the other devices. Fine. So, in order to differentiate whether I am going to enable the peripheral or the other hardware interrupts, we are supposed to use this bit, PEIE bit. Okay. So, this peripheral interrupt enable bit should be 1 to make the peripheral interrupts enabled. Okay. So, the timer 0 interrupt will not fall under this category. Your timer 1 and timer 2 only fall in this PEIE. Fine. So, this will make, if this is 1 in the sense, the peripheral interrupts are unmasked. So, if it is 0, which means that all those peripheral interrupts are masked. Okay. Fine. Then the most important, this is for T0IE is meant for timer 0. Okay. So, other bits are not required as of now. So, you just remember GIE and PEIE. Okay. So, on the next register that we are going to see is PIE1, which is peripheral interrupt enable register 1. Okay. So, in this register, the bit number 1, bit number 0 and 1 is meant for timer 1 and timer 2. Okay. So, this bit should be timer. Now, we are discussing only about timer 2. So, this bit should be made 1 to unmask the timer 2 interrupt, to enable timer 2 interrupt. That is the purpose of it. So, if we make this bit number 0 to 1, which means that timer 1 interrupt is enabled. Okay. So, this we will discuss later lectures about timer 1. Okay. Now, we are discussing only about timer 2. So, other bits are not necessary as of now. So, even though I will say you a small thing of it. So, this ADIE is meant for analog to digital converter. So, these two are meant for serial communication. Fine. Okay. Then this is meant for SSP. and then this is meant for capture compare mode. So this will discuss in the later lecture, capture compare interrupts. Okay, this is most important. Fine. Okay, so these are all the peripherals. Okay, as I have already told you, analog to digital converter, your serial communications are peripherals. So these interrupts, if you want to recognize all these peripheral interrupts, your PEIE interrupt should be enabled. So that's why we have discussed in the this thing. Okay. Okay, the next register is PAR register. This is a read register. Okay, so this is affected by the hardware itself. Hardware in the sense, as a programmer you can affect this one. Okay, you can just clear the bits of these bits of this register by software. By programming you can clear it, but you can't set the values of these register. Okay, so this register is similar to your PIE. Okay, the 6th bit is for analog to digital converter, 5 and 4 for receiver and transmitter, SSP, CCP. Okay, and last 2 bits are for timer 2 and timer 1. Okay, so this bit timer 2 will set, okay, whenever your timer 2 is overflow. Okay, so when now your timer 2 is overflowed, this bit will set automatically. Fine. If it is 0, in the sense timer 2 is not overflow. That's the meaning for that. So if we get this, if this bit is 1, which means that an interrupt has been occurred. So that's the meaning for this. Okay, so this bit is for timer 1. So this is the general interrupt structure of microcontroller. Okay, so these are all the interrupt sources. Okay, so this bit we do have individual AND gate for individual interrupts. Okay, so this will be having 2 inputs. So one is nothing but your interrupt signal, another one is enable signal. If both the things are 1, then only you will get output as 1 in the AND gate. Okay, so to recognize a particular interrupt, an interrupt should be occurred. That's the first condition, and the second condition is that the particular interrupt should be enabled. So if these two are 1, so if these two are occurred simultaneously, then only the interrupt will be recognized. So that's why we have given the AND gate here. Okay, an interrupt should be enabled, at the same time an interrupt should be occurred. Okay, so we do have such 8 other interrupt sources. Okay, so 8 other, why we are combined 8 other and then this timer 2 is these are all peripheral interrupts. So that's why we have combined here. Okay, so the timer 0 does not falls under peripheral interrupt, that we have discussed before. Okay, other 2 interrupts. Fine. So this will be constituted here, and if all these 12 interrupts are to be recognized, then the global interrupt enabled should be 1. So now did you got the logic? So why this is important? Okay, this is how the structure will be. If all these 12 interrupts should be recognized, then your global interrupt should be enabled. So that's why it's given to the AND gate. Okay, fine. So this is what the structure of interrupt logic in PIC microcontroller. So next we will see about timer 0. So this timer 0 is also an 8-bit timer. Okay, we do have separate register called TMR0. So this is also will work in the same fashion. Whenever it receives the signal, it will start to increment. Okay, so for this timer you can give the clock pulse by 2 ways. So one is the internal clock, another one is external clock. So internal clock, as I have already told you, we can take it from the crystal oscillator and you can divide it by 4, and then you can use it the signal for timer operation. Fine. And the second thing is external clock. So this external clock we can take it from the port A, 4th pin. Okay, don't forget that. Port A, 4th pin, RA4. Okay, so from this pin number you can connect an external device. So whenever you get the signal from the external device, that will be considered as a clock for this timer 0. Okay, this you can program it using the registers, that we will see how we can program it and all. Fine. So this timer 0 you can use it for the general timer operation and as well as for the watchdog timer. So in the feature itself we have discussed what is watchdog timer and all. Okay, So there I have told you a value will be given to the timer. So it will be decrementing automatically whenever it receives the clock pulse. So it should not become 0. So when it becomes 0, which means that the system is malfunctioning. So like that and all we have seen it. Okay. So without becoming 0, it has to be automatically reinitialized with the initial value. Okay. So this timer is used for that function. Okay. So at a particular time you can use it as for the timer operation or for the watchdog timer. We can't use this timer register for both the functions simultaneously. So that is not possible. So if you want to use this register as a watchdog timer, you should enable it. Okay. So unless it is enabled, it will be functioning as the timer register. Okay. So if you are using the internal clock, oscillator by 4 is the internal clock, fine. So if you are using the internal clock, then no need for prescaler value. Okay, no need for prescaler value in timer 0. Okay. So now we will discuss for the internal clock. So here we have connected an internal clock with the timer 0 register. It's an 8-bit counter. Okay. So this internal clock is delayed by 2 cycle. So since we are using the internal clock, it should be delayed for the 2 cycle. Okay. So if you have defined for 12 microseconds, 10 microseconds. So since we have introduced 2 delay cycles, it will be again defined for 12 microseconds. Okay. So whenever it receiving the clock pulse, so for each and every clock pulse, this timer will start to count. So when this timer overflows from 00 to FF, an interrupt will be generated by this timer 0. Okay. So this timer 0's enable bit is in the interrupt control register. So you just see here in interrupt control register. So the bit number 2 is for T0IF. Okay. So and bit number 5 is for T0IE. So this is enable bit and this is interrupt bit. Okay. So whenever this timer 0 is overflowed, so this bit will set automatically. Okay. So that's why it's given here. Okay. So then bit number 5 is for enable bit. This bit should be 1 to recognize this interrupt. Okay. And then as well as timer 0 works. Okay. So if we connect, for example, if we connect here, I have explained for internal clock. So if we connect an external clock, okay. So if this is your timer 0 register, okay, I am supposed to use the prescaler register. Okay. So RA for port A, 4th pin, I will give the clock pulse. Okay. So for every clock pulse, so if I set this to 1:4 in the sense, for every 4 clock pulse, it will give one single clock as an output. So whenever this timer 1 receives the clock pulse, it will start to count from 00 to 01. Okay. So for every 4 clock pulse, again it will give another clock pulse. When it receives another clock pulse, it will be incremented to 2. So whenever it is incremented and reaches FF, it will generate an interrupt. Fine. So then the process is same for, so this process will be same for the external clock pulse also. Okay. So if I give the internal clock pulse as an input for this timer 0, prescaler is not required and it will be delayed for 2 clock cycle. Okay. So the operation will be same for both. This timer operation and the interrupt will be same for both internal and external. So if I give external clock pulse as an input, a prescaler should be used. Okay. So this is how the timer 0 will work. So now we will see how this timer 0 is programmed to be used as timer 0 or watchdog timer, how the prescaler value can be set and all. Fine. Okay. So for programming this, we do have a register called option register, OPTION, option register. Fine. So in this, the bit number 0 to bit number 2 are used to set the prescaler value. So when we use external clock, okay, this prescaler value is used only when we use the external clock RP4. Okay. So then PSA, which is nothing but prescaler assignment. Okay. So as I have already told you, this timer 0 can be used for timer function and as well as for watchdog timer. Okay. So this bit will define whether we are using this prescaler value for the timer or for the watchdog timer. Okay. If this is 1, then it means we are using it for timer. If it is 0, then it means we are using it for watchdog timer. So that's the purpose of prescaler assignment. Fine. And the next thing is timer 0 select edge. So now we are defining that whether this clock pulse that we are given here for the timer, either we are selecting the rising edge or falling edge. Okay. So I have told you, for every 4 clock signal, this will this prescaler will give an output 1 clock signal. So now we are defining for every rising edge or every falling edge are we counting this output. Okay. So if this bit is 1, in the sense for every rising edge this will count as 1. Okay. So if this is 0, which means that we are counting with the falling edge. So that's the meaning for TOSE. And next thing is timer 0 clock select. Okay. So I have already told you this can be used for timer function or for the watchdog timer. So whether if we want to use this clock, input clock, either it can be internal or external, we want to use for timer function or watchdog timer. So if it is 1, in the sense we are using for timer, if it is 0, it means that we are using it for watchdog timer. Okay. So this will define, the bit number 2 will define the prescaler assignment. Okay. Whether we are using this prescaler value for timer 0 for timer or for watchdog timer. So this will define whether we are using this clock for timer function or for the watchdog timer. Okay. So these 2 bits are not necessary as of now, you just know these bits of option registers. Okay. So as I have this is the function of timer 0. Okay. So the timer 2 and timer 0 we have discussed. So both of things are 8-bit timers. You can use it for generating a time delay, you can use it to count an event or to decide the time period of a particular event. Okay. So the timer 2 register, okay, so you can control it using the PR2 register and then PIR, PIE, okay, and then interrupt control register we can control it, and the timer register that we use is TMR2. Fine. So here in timer 0 we can use it as a watchdog timer also. We will control it using the option register and then interrupt control register. Fine. So in later video lecture we will see about the timer 1 functions.